This is our linear versus exponential video. Jimmy owns a lawn mowing business called Gracious Lawn Mowing. He charges $15 up front plus $5 per hour. How much would he charge someone for 4 hours of lawn mowing? How long would he have to be mowing a lawn to earn $85? Here are my equations. The recursive rule is next equals now plus 5, and it starts at 15. The explicit rule is T equals the total amount of money per job, H equals hours. So T equals 5H plus 15. So, how much would he charge someone for 4 hours of lawn mowing? Well, you gotta plug it in. So, T equals 5 times 4 plus 15. And 5 times 4 is 20. And then you gotta add 15, that's $35. How long would he have to be mowing a lawn to earn $85? So you plug it in for T, and then you subtract 15 to get 70. 70 divided by 5 is 14. So it would take him 14 hours to get $85.
Thank you. Let's go.
So I did exponential growth. There is a major hurricane forming on the east coast of the United States. Meteorologists have said that the wind speed of Hurricane Dee Dee started out at 140 miles per hour. From there, the meteorologists predict that the wind speed will increase by 6% each hour. So because it's increasing by 6%, it would multiply each time by 1.06. So the recursive would be next equals now times 1.06, and it would start at 140. So, and the explicit rule would be y, it has to be in the format of y equals the start point into the growth factor to the power of x. So y is equal to 140 into 1.06 into the power of x. So y is the wind speed and x equals the number of hours. So what will the wind speed of Hurricane Dee Dee be at the 20th hour? So you have to round to the nearest hundredth. So what you would do, you have to plug the exponent into the equation. So 20 would represent the number of hours, so that would be x. So you would plug that in for x, so that would be y equals 140 into 1.06 to the 20th power, and that would equal 448.99. Round to the nearest hundredth would be 448.91, and round to the nearest whole would be 449 miles per hour. So at what hour would Hurricane Dee Dee's wind exceed 400 miles per hour? And you have to use the table in your calculator. So first you have to enter the equation y is equal to 140 into 1.06 to the x power into your y equals on the calculator, and then once you put that in, it will be on your table. So you have to find when y is greater than 400 and when x corresponds to that y. So it would be at the 19th hour at 423 and 58 miles per hour.
Katie gets an allowance of $500 every 3 years. This year, she wants to pay for Netflix, which is $9 a month. How much money will she have at the end of the 3 years? How many months have passed if Katie has $275 left? The recursive rule is next equals now minus 9, the start of 500, and the explicit rule is y equals 500 minus 9x. Y is the total amount of money left, and x is the number of months passed. For how much money will she have at the end of 3 years, you have to plug in the number of months for the 3 years, which is 36 months. So it will be y equals 500 minus 9 times 36, which equals y equals 500 minus 324, which is 176. So it will be $176 left. For how many months have passed if Katie has $275, you have to plug in the $275 for y, leaving 275 equals 500 minus 9x, which equals down to negative 225 equals negative 9x divided by negative 9, x equals 25, so it'll take 25 years for her to have the $275 left.
This is the exponential decay problem. So one day, Jack bought a Ferrari for $1 million. Sadly, his car has a depreciation rate of 20%. How much will the car be worth in 5 years? When will it reach $500,000? The recursive equation start is equal to a million and next equals now times 0.8. And the explicit equation is y is equal to a million times 0.8 to the x power. The y is equal to the cost of the Ferrari and x is equal to the number of years. This is my table right here, and this is my graph. So question 1 was, how much will the car cost in 5 years? So I used the explicit equation, 1 million times 0.8 to the 5th, and I got $327,680. I got this answer by using my explicit equation and substituted 5 for x. I got the answer there, which is $327,680. And the second question was, when will the car reach 500,000? I said between 3 and 3.25 years. I put it in my equation into y1 and used the table to get this answer.